What is a buck converter in power electronics? Have you ever wondered how devices manage to get the right amount of power without wasting energy? One key player in this process is the buck converter. So, what exactly is a buck converter in power electronics? Let's break it down. A buck converter is a type of direct current to direct current power converter. Its main job is to take a higher input voltage and step it down to a lower output voltage. At the same time, it increases the output current. This is especially important in power systems and renewable energy applications, where efficiency is a top priority. Unlike linear regulators that waste energy by turning excess voltage into heat, buck converters are much smarter. They use switching elements and energy storage components to minimize energy loss. In fact, many buck converters can achieve efficiency levels that exceed 90%. The operation of a buck converter revolves around a high-speed switching transistor, often a metal oxide semiconductor field effect transistor. When this transistor is turned on, current flows from the input through an inductor to the output. The inductor stores energy in its magnetic field during this time. When the transistor is switched off, the inductor releases that stored energy to the load through a diode or a synchronous switch. This clever switching action helps maintain a steady current flow. The average output voltage is controlled by adjusting the duty cycle, which is the ratio of the time the transistor is on to the total time of the switching period. This allows for precise regulation of the output voltage, ensuring it is lower than the input voltage. Key components of a buck converter include a high-side switch that connects the input voltage to the inductor, a diode or low-side switch that provides a path for the inductor current when the high-side switch is off, an inductor that smooths energy transfer, and an output capacitor that filters voltage ripple for a stable direct current output. Buck converters usually operate at switching frequencies that range from hundreds of kilohertz to a few megahertz. Operating at higher frequencies allows for smaller inductors and capacitors, which reduces the overall size of the converter. However, this can slightly lower efficiency due to switching losses. In the context of power systems and renewable energy, buck converters are vital. They efficiently step down voltages in applications like battery-powered devices, solar power systems, and electric vehicles. For instance, they convert the higher voltage from a battery or solar panel to the lower voltage levels needed by microprocessors, sensors, or other electronic components. Their ability to provide regulated, efficient, and compact voltage conversion makes buck converters essential in modern switched-mode power supplies and power electronics design. So next time you use a device powered by batteries or solar energy, remember the buck converter working behind the scenes to keep everything running smoothly.